All right, last week we actually talked about arithmetic sequence, and on the board I've given you the recurrence relation or recurrence rule for arithmetic sequence and the general rule for arithmetic sequence. A is the first term and D is actually the difference. So you look at the sequence, when it goes up by a certain number, and that is a constant, and that's a geometric, that's a arithmetic sequence, that's a constant. All right. Now, for geometric sequence, what I'm going to do today is make sure that you understand what a geometric sequence is. It has a common ratio. You have to be able to derive a recursive rule, which you have done that in the paper just now. Derive an explicit rule. That's the one that you need to know, and find the nth term of a geometric sequence. And finally, given two terms of a geometric sequence, find the common ratio, first term, and hence the rule. All right? So this is what we need to go through today, and we should be able to do it. Now, let's revisit what the examples I've used. Look at A, B, and C. The focus question is now why? What makes B a geometric sequence? Right? What makes B a geometric sequence? So we are going to look at the reason why. You can see that that one is actually double. Double the previous number, correct? Yeah? Now, geometric sequence. So the definition of a geometric sequence is a sequence of numbers such that the ratio between any two successive numbers of the sequence is constant. All right? So a geometric sequence, also known as geometric progression. Now, the way you work out the ratio, you look at two successive numbers. So you use the second number, divide by the first number. You will get 6 divided by 3, which is 2. 12 divided by 6, which is 2. 24 divided by 12, which is 2. All right? This is how you find the ratio. The second number divided by the first number, or the third divided by the second number, and so on and so forth. All right? So that's wrong. That's not arithmetic. That should be geometric sequence. All geometric sequence graphs are non-linear or exponential. All right? You might be asked to describe the graph. Again, with the graph, you should always just use one single dot. All right? You can see that this is actually an exponential function. All right? If I connect it, this is actually an exponential function. Right. So you generally don't connect that.
Can you go back to the last slide?
Yep, sure.
Is it an arithmetic or a geometric?
It's geometric. Right. That is my fault. All right. So if you can see, it's actually an exponential function. So each one, the subsequent term is what the first term, the previous term times 2. All right. Now, here the example. Let's have a look at example 1. You've got it in your sheet in front of you. From the list of 5 sequences below, can you identify the type of sequence, whether it's geometric, arithmetic, or neither? Work out whether there's a difference or ratio.
So a geometric sequence is the ratio that you multiply. So the ratio between any two successive numbers is the same. Yeah, basically. C is a half. Did you get it? I broke my settings. back to there. Let me see. 'Cause that's I remember. He'll eventually show you how to do it.
And also, how did you do that before where it came up as like, there was a little like, something equals and then you can type the original number.
All right, do you agree with me? So what I've done with the first one is I just look at
But
the
can you
second
get-
one
so you
divided by
can't get
1.
that, the explicit.
By the first numbers. You can see that A, everything is multiplied by 2. All right, the subsequent number is the previous number multiplied by 2. So therefore, it is geometric. B, the subsequent number is the previous number plus 4. So therefore, it's arithmetic. C, either divided by 2 or multiplied by half, and that's geometric sequence. Whereas D is neither geometric or arithmetic. And finally, E, you divide, like for example, term 2 by term 1, 2x divided by x will give you 2. All right. So you therefore, and also you need to really confirm 4x divided by 2x is 2. Now, the exam tip. Sometimes in the exam, you are given a sequence. All right. You are asked to prove the sequence that it is geometric. You cannot just do one calculation. You need to do a minimum of 2 calculations. So that, come on. All right. Now, in the exam, if you're given a sequence and you're asked to prove that the sequence is geometric sequence, you cannot just find one out. That is not right, because you've got to make sure that the ratio from, say, first number to the second number is the same as the ratio from second number to the third number. All right? Always make sure that. Can you write that down in your notes, please? I have seen exam question like that, and heaps of people just calculated one out, and that's a mistake. All right? Please remember that. Just make a note. There's a exam hack that you need to know. Anything, if you ask to prove, you would need to make sure that the ratio are the same. You need to calculate at least 2 ratios. Yep.
This is just not related, but how do you get the sum on the?
Later. All right. All right. Let's go on. Recursive rule.
So is that how you find?
So, look at the geometric sequence here. The recursive rule you should know. So I'm going to run through it very briefly. You must always take T1. All right. It's important. Work out the ratio. That is a common ratio. And to work out the common ratio, you use Tn plus 1 divided by Tn, or Tn plus 2 divided by Tn plus 1. All right? That is how you need to do it. And then, first term is always A. The ratio is Tn plus 1 divided by Tn. Everybody happy with that? I'll move on. So, for the recursive rule, this will be given in your formula sheet. Tn plus 1 equals to R times Tn, and T1 equals to A, where R is the common ratio and A is the first term. All right? That is in your formula sheet. You should know that. Geometric. Did I say? I use a template, you see. It is geometric. My fault. I use the same template, that's why. Next. Let's have a look at this example here. How will you describe this rule? Describe the rule, like starting from 16, the next number is
Times
40%.
Yeah, or you can use the next number as 40% of the previous number, can't you?
Yeah.
All right, it's your own words. So use your own words if you're asked to describe. Now, you should be able to work out T2.
Alright, let's eat. Let's eat.
If you ever got a calculator, how are you going to do it?
It's like, oh, what's that?
Multiply. All right, write it down. If you're not sure, you know, use 16. Multiply by 4 first. All right. Is 64. So is 6.4. All right. So T2 is 6.4. And then the next bit, of course, you need to use your calculator.
Would it just go in the recursive section? Would it just go in the recursive section? And then you're just putting yeah.
Use your calculator. Generally, they won't be so cruel, I don't think, to get you to give out to calculate the 5 numbers. Yes? Oh, you describe use it on word like starting with 16. The next number is the previous number multiplied by 0.4, or the next number is 40% of the previous number. Yeah, explain the rule. So describe the rule means explain. All right, let's go on with the next one. Now, can you determine the recursive rule for the following sequences? And they are all geometric. Work out the ratio, please. Make sure that you work out at least 2 of the ratios. Now, I want you to take particular notice to question C. All right? Now, if you look at question C, is it an exponential function?
It's going to be negative.
Yes.
Negative, also negative.
Yes or no?
Like negative 2, and then the ratio
It's actually non-linear, but question C, you can't really describe it as exponential because you're going to from negative number to positive, and then negative, and positive, and negative, and positive. Right? So it's actually go up and down, up and down, up and down, up and down. So if you're asked to describe something like this, it's just non-linear. Yeah? It goes from negative. The first number is negative, right? And then go up, and then down again, and up and down. So, think about geometric sequence. If you've got a positive number, it will go out in an exponential function. It will go up positive number, it will go up this way. Negative number, you know this one. If when n is 1, it's minus 2. Let's say this is x-axis. And then 4 minus 8, 16. Right? So the negative number makes this graph look like this if I join them together. All right? And it goes up and down. It's not really exponential. It's just non-linear when you describe it. All right? Now, let's move on. All right, this is calc 3. Ooh, that shouldn't be there because I haven't done the explicit rule yet. Let's have a look at the explicit rule first, then we come back to this question. All right, that should have been example 5. Now, let's consider this first question. What you can see is, if I set it up this way, T1 equals to 2, T2 equals to 2 times 2, 4 times 2, 8 times 2. 2 is actually the ratio. All right? So 2 is r to the power of 1, r to the power of 2, r to the power of 3. What do you get when you go to n? R to the power of n take away 1. See, that is 2 take away 1. That gives you 1. 3 take away 1 gives you 2. 4 take away 1 gives you 3. Alright? Yeah? So, the general rule or the explicit rule for the geometric sequence, Tn equals to a times r to the power of n minus 1, where r is the common difference and a is the first term. So I'm going to go to the general rule now. Here, the recursive rule, Tn equals to r, Tn plus 1 equals to r times Tn, T1 equals to a. The recursive rule, Tn equals to a, which is the first term, times r, the common ratio, n minus 1. All right? You should know both of these rules. All right, I'm going to move on. Let's start by determining the explicit rule for the following geometric sequence first. Use your calculator because you need to use your calculator to find out what R is. All right? So let's do A. What's happening here? Let's do A. I'm not sure what's happening with my thing.
Wait, what number did you use for because you already know it's geometric. So just figure out the 2.5 divided by 2.
Right. It's not working. I'll use the whiteboard. All right. If you look at this, A, 2.5 divided by 2, what does it give you? 3.125 divided by 2.5, what does it give you? Use your calculator.
That's quite so
Yep.
you have to do you have to do 2 because you already know it's a geometric sequence.
Sorry?
Can you only do one of those?
Well, you got to confirm it.
Alright.
Generally, you confirm it because it's only one
Right.
extra seconds, perhaps.
Yeah.
So you're so close.
So R is actually 1.25, 1.25.
Okay.
All right. So therefore, Tn equals to 2 times 1.25 to the power of n minus 1. All right? Now, if you have a negative number, I will advise you to put a bracket. It's worthwhile having a bracket if you have got a negative number.
That's fine.
And the next one, R equals to minus 0.84 divided by minus 3 equals to 0.28. All right? Yeah, I'm not going to do 2. I'm a bit lazy here, so I'm going to use the 0.28. So let's do Tn, therefore equals to 2, minus 3. Again, I'll use a bracket, minus 3 times 0.28 to the power of n minus 1. All right? So that's how you should do it. Work out the R. Now, let's go to example 5, please, which is this example. I would like all of you to try it first before I show you my answer. All right? Try it first before I show you my answer. First thing is to work out the common ratio.
That's the recursive. The second one's recursive.
Yeah.
Yeah, and that's the explicit.
Easy, buddy.
Now, part D is an interesting one. Look at the odd and the even terms.
Wouldn't it be negative?
Yep. Definitely. Because you need to look at the odd terms. You see, all the odd terms are actually negative. All right. Let me review my answer. So if you use 3 divided by negative 0.3, you know that it's 10. All right? And then, oh, I did not do the other one. Minus 30 divided by 3 is minus 10. So therefore, Tn plus 1 equals to minus 10 times Tn. All right? Happy with that?
Yeah.
Let's go on to example 6. Now, you're given the explicit formula for a geometric sequence. You need to determine the 10th term in the sequence and then determine the recursive rule for this sequence. So what is A and what is R? Which one is A? 4. And R, this one is A, this one is R. Right? So therefore, when you determine the 10th term, you can just put in T10 equals to 4 times 2 to the power of 10 minus 1, which is 9. Which is, I'm pretty sure it is 2048. Yeah, pretty sure it's 2048. Since you know T1 equals to 4 and R equals to 2, so therefore the recursive rule is Tn plus 1 equals to 2 times Tn. T1 equals to 4. Now, can you all grab your calculator, please? Because I'm going to quickly show you how to use your calculator for this. All right? Your class back. So you know Tn equals to 4 times 2 to the power of n minus 1. All right? Or Tn plus 1 equals to 2 times Tn. T1 equals to 4. Calculator. All right? Let's go to your sequence. Everyone got a calculator?
Yep.
Let's learn how to do it. Let's go to sequence. So this time, what you need to do is again delete everything, edit and clear all. Always do that for a new question. Always do that. So here, if you want to put in the recursive rule, you know the type is A1, not A0. We'll talk about A0 a little bit later. We're going to start off with A1 first. So Tn plus 1 equals to 2 times Tn, which is An in this case. And A1 is actually equals to 4. Tap on that, and then go. You can see the sequence. Now, if you want to look at the sum, some questions will ask you for the sum, not all of them. You need to tap on this diamond, this little diamond, and the first one, sigma display, which is a sum display. Tap it on, and then you can see the sum on the next column.
So Alan.
All right. You got to be up here before you can do that. You got to be in the
Where would you?
top box. You got to switch to the top box before you can do
And
that.
will it
All right.
stay on until I tell it?
For the explicit rule, let's do the explicit rule. Just try the explicit rule. This time, I'm going to do something different. This time, I want you to use a negative in front. -2. So that you can see what it is like. So 4, this time is, I want you to do 4 times, use a bracket. -2 to the power of n. Oops, hang on. I'm going to put a bracket in, and -1. All right? And -1. And don't worry about the display, the sum of the display. Just go tab. It went from 4 to -8. Now I'm going to show you something on the class pad. Did you all get this? Yeah? This button here actually will show you the plot of this. Yep. So if you tap on that, this is what it looks like. Now ClassPad will show you everything. Will show you the line. So if you ask the plot, just remember you don't need the line. You can see that go up and down, up and down, up and down. So it is non-linear, but it's not exponential in this case. All right? That's not a good one to do it. Doesn't matter. All right, let's go back. Let's go back to your lesson slide. All right, next, example 7. This time, you've got a geometric sequence T2 equals to 14 and T4 equals to 56. You need to determine a common ratio and then state T1, then find the explicit rule and determine T5. All right? So, what I'm going to show you is a method of doing it. So you know T2 is 14. We don't know what T3 is. We know T4 is 56. All right? Using a different color. Now, T2 is 14. T3 is actually the ratio times T2. Correct? Yeah?
Yep.
And T4 is the ratio times T3. And you know that T3 is R times T2, which is R times R times T2. Correct?
Yep.
Yeah? So therefore, it's R squared times T2. Now, we know T4 is 56. 56 equals to R squared times T2, which is 14. Yeah? So R squared equals to 56 over 14. Do you agree? Yeah? Yeah? All right. So if it is T2 is 56 over 14, so we know that R squared equals to 4. R therefore equals to 2. All right. Now, I'm going to give you a general way of doing it. Using a different color, I'm going to write it down. If you've got TA equals to something number, let's say X, all right, TB equals to Y, all right? If you want to find the ratio is actually, if B is greater than A, is Y over X, R to the power of B minus A is Y over X. Alright? Makes it a little bit simpler if you know that. If TA is X, TB is Y, the ratio R is simply B minus A. R to the power of B minus A divided by Y equals to Y divided by X. And then you can use your calculator to work out what R is. Alright? Now, therefore, part B, you can work out what T1 is. T1 equals, T1's R times T1 equals T2. And therefore, T1 equals to T2 divided by 2, which is R, which is 14 divided by 2, which is 7. Alright? And now you can state the explicit rule. The explicit rule is Tn equals to A, which is 7, times the ratio is 2 to the power of n minus 1. See, if I put n equals 1 in, 2 to the power of 0 is 1. So 7 times 1 is 7. This is how you think about it. And then you can determine T5. 7 times 2 to the power of 4, which is n minus 1. 7 times 16 equals to 124. All right? $112, sorry, my fault. I'm half asleep. 112. Alright. I'll get this question wrong if it is a count free. Alright, last example. Last example, you need your calculator. You need to find the ratio first. Remember what I say, the ratio now I've seen questions like this in Calc 3 as well. So you need to know some cube. For example, this one it will work out to be
27.
R cubed equals to 27. So R equals to cube root of 27 is 3. Alright? Yeah. I don't think something which is to the power of 4 will be in Calc excuse me, Calc 3. I don't think, I haven't seen, but to the power of 3, yes, I've seen. So therefore, you can work out what T1 is. You know T3, you can work T1 out. you definitely need to use your calculator. Use your calculator, you should list two numbers.
How do I get off this and into that
One,
no,
which is
what he said.
just
Yeah.
which is smaller than t, which is smaller than 10,000. The other one should be larger than 10,000. So if I've done it correctly, I've got T8 as 8748 and T9 as 26244. Part A, I've worked out from T3, I work out T2 and I work out T1. And then Tn equals to 4 times 3 to the power of n minus 1. Alright? And then use your calculator, you can work out T8 and T9, and therefore term 9 is a term of the sequence which will exceed 10,000. So what I've done today is just really taught you geometric sequence using the recursive rule and general rule. You should know the recursive rule already. General rule is something new today. All right, I'm going to stop here. And for those of you who have not finished, just very quickly, a summary, a geometric sequence. It's a sequence of numbers such that the ratio between any two successive members of the sequence is a constant. So you've got a recursive rule and you've got an explicit rule. Know that R is the ratio, the common ratio. And A is always the first term. All right. So I'm going to stop here. And for those of you who have not finished the worksheet yet, can you please spend the time and finish it? If not, there should be you should be doing some work from club.